Hello, I'm Rebecca the Maths Lady, here to help you make sure all your children become confident, creative and fluent mathematicians. Today we're going to be tackling the Year 6 topic of multiplying fractions, which I know is a topic that strikes fear into the heart of most teachers. Let's have a quick look at why that fear happens. So a typical question would be something like 2/3 times 4/5. And teachers tend to look at that and go, I'm sure I knew how to do that once. And then they look through their notes, they look online, and it gradually comes back to them that they did calculations like these by multiplying the tops or the numerators to get the numerator of your answer and multiplying the denominators to get the denominator of your answer. So the answer to this calculation, 2 times 4 is 8. And 3 times 5 is 15. So the answer is 8/15. But the problem is, as a teacher, your children are going to ask why. And that's scary. And you're probably not very comfortable with the fact that you couldn't remember that method. You want children to be able to deeply understand their maths so that even if they've forgotten the method, it'll come back to them. So that's what we're going to cover today. We're going to cover how to teach this topic in ways children will deeply understand and will always remember. And even if they forget it, they'll be able to rebuild it in their mind. So the first thing you need to understand that is that array is the universal structure for multiplication that unites all shortcuts, all methods. If you and all your children deeply understand array and how it is multiplication, then you will always be able to share all your thinking and all your strategies together and understand each other. So we introduced array way back in infants when we were talking about a calculation like 5/3. By organising that multiplication as a rectangle, which is what array is, suddenly we can see we can actually do 5/3 by counting in 5s, 5, 10, 15, instead of actually counting in 3s. And we start to bring together the different strategies people use to find shortcuts for multiplication. And it continues from there right through primary maths and way beyond that. Now, by the time children are 9 years old, we've usually stopped using actual objects for representing multiplication in rectangles as array and have moved on to first using counters to represent those objects and then using squares. So if you considered a calculation like 3 times 9, you could draw that as a rectangle that's 3 squares high and 9 squares long. And all the children have to do to calculate the answer is to find a way of counting up the squares in that rectangle. And they may count them in 3s, they may count them in 9s. A child might see that as 3 times 10, but with 3 missing, so they get their 30 and then subtract 3. I've seen children split the rectangle like this into 3 3x3 squares and go 9, 18, 27. Doesn't matter what their instinctive strategy is. If you have an array, everything that's true and correct makes sense together and you can all share your strategies. So it's a basic understanding of array that you need to have. And we tend to use squares, and we'll certainly use squares and rectangles today, because squares can be beautifully cut in half or into smaller fractions or into any parts. And also because they often have exercise books with squares in, which are nice and handy, or it's easy to get squared paper. I find 2 centimetre squared paper is quite useful for this topic, so might be worth getting some of that. So in introducing this topic, the first thing that we want to do is review the Year 5 topics that lead into this. And the Year 5 topics are, just read from the curriculum, multiply proper fractions and mixed numbers by whole numbers. So what does that mean? Proper fraction is just any fraction that's less than 1. So multiplying a proper fraction by a whole number, we could be looking at something like 2/3 times 5. Proper fraction by a whole number, they should have done quite a bit of this in year 5. And ideally they've done it as array because it unites all the strategies, but they may not have done, so it's a great time to recap that. So to calculate the answer to this, you need a rectangle that's 5 squares long and 2/3 of a square high. Terrible drawing? It doesn't matter. It's easy to follow. If it's not, for some children, you may need to do this more slowly. And if somebody has a great PowerPoint in this, feel free to link it into the comments, or worksheets that you can download for possibly for a small charge. They'd be very much welcome here. So 5 squares long, 2/3 of a square high, and in drawing the 2/3, I've drawn it in thirds. So we're counting 1, 2, 3/3, that's 1. 1, 2, 3/3 is 2. 1, 2, 3/3, that's your 3. And we've got 1/3 left over. So the answer is 3 1/3. Now a child might simply have counted the thirds, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and got the answer as 10/3. And they may have counted them in different orders or seen them in blocks in different ways, but it should be possible to link all those strategies with the diagram to see that everyone is doing the same thing and everyone is getting the right answer. Whether they've got 3 1/3 or 10/3, it's actually the same thing. So it's really worth spending some time working on these. You might want to start with calculations where you've drawn the array for them and they're just counting up the parts of shapes, and then move on to ones where they actually have to draw the array themselves, which is a big challenge. Judging fractions of a square like 2/3 or 2/7, it's quite tricky, but it's a good challenge, especially if the children are working in groups and sharing their strategies and helping each other out. It's a challenge that's just the right level of stretch for most children. So the other part of the Year 5 curriculum that I just mentioned there was multiplying mixed numbers by whole numbers. So we might try a calculation like 2 1/3 times 4. And hopefully by now you're guessing that this is going to become a rectangle that's 4 squares long by 2 1/3 squares high. So 2 1/3 squares could look like this. And the children can now count. There's 8 squares there, and we've got 3/3 there, so that takes us to 9, and 1/3 left over. So the answer is 9 1/3. Child might have got 8 4/3, and it's useful to look at that equivalence. If children move on to larger or harder numbers, if you consider this one, 32 times 2 1/3, it is absolutely fine to move away from using squares. Just draw a rectangle. This is going to be 32. That's going to be 2 1/3. So we might sketch in the 2 1/3. And then our 32 times 2. Well, we've got 32 squares along the bottom row, 32 squares along the next row, and then in the top row we're going to have 32/3. 32/3, going to have to change that into a mixed number. Well, 30/3 is going to be 10, so that's 10 2/3. So the answer is going to come from 32 plus 32 plus 10 2/3, which is 74 2/3. There's plenty in this topic to keep everybody busy and challenged, and your most able children should definitely be working with any children who are struggling to help them visualize the easier calculations here. It's so important the whole class can do calculations like this one, 2 1/3 times 4. And then it's lovely just to pop in a little extension challenge, which is going to get us ready for our target teaching point. Look at a question like 2.5 times 2.5. 2.5 times 2.5. Hopefully you can see by now that we can do that if we just draw a square that's 2.5 squares high by 2.5 squares wide. We can count 1, 2, 3, 4. We have 2 half squares here, so that would be 5. 2 half squares there, so that would be 6. And this bit here, that's a little quarter square. So therefore the answer is 6.25. Quite doable, really. Your children did areas of irregular shapes in year 5, so counting up something like that and doing it accurately and coming to the conclusion that's 6.25 is perfectly accessible. If they're struggling with that, it's worth focusing on it and getting the class to work on it together. So now let's get to our target teaching point of multiplying fractions. Let's start with a nice easy one. 1/2 times 1/2. Can you visualize it? How big's your rectangle going to be if it's 1/2 a square wide and 1/2 a square high? See? 1/2 a square wide and 1/2 a square high. It's a quarter. Did you see that? It's really worth taking the time to make sure that you can. So 1/2 times 1/2 is a quarter. Let's try another one. What about 1/3 times a quarter? Well, by then it's becoming quite tricky to draw that in one square. So what we'll do is draw ourselves a nice big square here and cut that into quarters. We only want one of them. That's 1/4. And into thirds the other way. That's 1/3. And so the area we want is that one, which is 1/12. And that is the correct answer. You could get that by multiplying the numerators and multiplying the denominators. And if this question had been 1/3 times 3/4, well, we would have gone 3 times as high to get our 3/4. And the answer would have been 3/12. And again, it fits with multiplying the numerators and multiplying the denominators, 3/12. Let's move on to a harder question. What about a question like 5/7 times 2/3? 5/7 times 2/3. Well, we're going to need a nice big square. So 2/3 is here. 5/7, that's going to be tricky to draw. Well, we want an off-centre line, and we're going to cut the smaller side into 3 and the larger side into 4. So our 5/7 will be this much. This was 2/3. And the answer that we're looking for is this much, which, if we look at the total number of parts, 1, 2, 3, 4, 5, 6, 7, 14, 21, and they would all be equal if my drawing was perfect, which of course it should be. And the number of parts in our answer is 510. So our correct answer is 10/21. Now at this stage, it's worth taking the time to notice what's going on here. Because this 21, the total number of parts, always comes from splitting the total shape into this number of parts in one direction and that in the other. So the total number of parts can always be found by multiplying the denominators. Just make sure that you're comfortable with that. The total number of parts in the whole square comes from multiplying the denominators, because you've split the square into this many parts one way and this many the other. So if you multiply those numbers together, you get the total number of parts in the whole square, and therefore the denominator for your answer. The total number of your parts in your answer comes from the shaded rectangle, shaded in green here. And the height of the rectangle comes from one of your numerators, and the width of it comes from the other numerator. So the number of shaded parts comes by multiplying the numerators. So this is where your standard methods of multiplying the numerators and multiplying the denominators to get your answer comes from. It is logical. And it is a great shortcut. It's just a problem if your children haven't done this underlying work, because it's a spell, it's witchcraft, and they're going to forget it. It won't really make sense. And we need to be laying solid and secure foundations for them to understand their maths. Now, cutting squares up like this is quite a challenge. It's a good challenge for children to be working on, but many will struggle. One of the reasons I've done this freehand is because I want children to know that it's okay to do it freehand and just to use your brain to know that the parts are equal, because that's what they're going to have to do. But some children are really still going to find that difficult. So let's just look at a method which helps those children who are finding this difficult and which all children should find interesting. So if we look at a question like 2/5 times 3/8 and go back to our squared paper, instead of starting with a square and cutting it up, we can build this up from individual squares. So we can show 2/5 by having a rectangle that is 5 squares high, and 2/5 of that is going to be 2 of those squares. And we can show 3/8 by making our rectangle 8 squares wide. So if we start with a rectangle this size, the size of the denominators, 5 in width and 8 in length, then to do 2/5 is simply that, and to do 3/8 is simply that, and the area that we want is that. And that is 6 squares out of 8 times 5 is 40. But they can count them up one at a time if they're just needing that security. And you may see this method in some books. And it's fine as long as the children understand that that is 1 unit and this is their answer as a part of that. I hope you've enjoyed today's video and you're now really confident that you can bring this topic alive for your students. It is worth spending a good week on it, because if you teach it in this way, they will really get it, but you'll also be reviewing so many other aspects of the primary maths curriculum and connecting them all together in a deep way that will lay wonderful foundations for the future. If there's any aspect of it you don't understand, please leave a comment. If you design resources, worksheets or PowerPoints that support what I've just explained here, please share links to them in the comments. You're really welcome to do that. If you like this video, please click on subscribe and then click on the bell so you get notifications of other videos. I promised to do a pair to this one on division of fractions by whole numbers, which is another Year 6 teaching point, so I'll do that this week too. But if you'd like any others in particular, I've done the whole of reception class. I'm working through Year 1, but I don't mind stepping out of sequence to answer somebody's question. There is a Facebook group which accompanies this YouTube channel. It's the Expert Primary Maths Teacher Planning Facebook group. There to support the teachers who want to be expert teachers, who can work beyond and around the schemes of work they're given, or write their own schemes of work straight from the curriculum. I'm Rebecca the Maths Lady. Thanks for watching. Have a great day. Bye.